Yulia Sion. I am a researcher and industry expert in haptics and wearable technology. Today, I will be discussing the psychophysics of touch and how we communicate emotions through skin. And my speaker today is Greg Gerling. Greg is a professor of systems and information engineering at the University of Virginia, courtesy appointments in mechanical and biomedical engineering. His research interests include haptics, computational neuroscience, biomechanics, and human-computer interaction. Greg is currently the chair of the IEEE Technical Committee on Haptics and an associate editor for IEEE Transactions on Haptics. Long intro, lots of stuff done. Hello, Greg.
Hello, Yulia.
How are you today?
I'm great. Thanks for having me.
Thanks for joining me and talking to me about psychophysics of touch. I'm very curious because you do lots of fundamental research on touch, actually, which is super interesting because I have a feeling as a researcher myself in haptics, there is a lot we don't know yet. We'll touch upon this in some of the questions that I have for you. But usually I start my conversations by actually asking people why they do haptics in the first hand, right? Because there are not so many hapticians. And so same question goes to you. Please tell us why haptics, why research in this particular field?
Yeah. So haptics, and when I talk about haptics, I mean Haptics Symposium and World Haptics Conference and Asia Haptics and Euro Haptics. It's a really welcoming community. And I kind of got sucked into it, maybe in part because it's such a welcoming community. And maybe I'll just tell you a little story at the beginning.
Sure, I love stories.
So I was at the 2005 inaugural conference, World Haptics, and I didn't know that at the time, actually. I was a PhD student, and I was doing work studying the skin and the microstructures in the skin. And I attended that conference, and I look out into the audience, and this researcher, Srinivasan, and I always read in his papers, M.A. Srinivasan, was sitting right in front of me in a crowd of about 500 people. And I knew everything about all his papers. And at the end of my talk, he actually asked a question. And I couldn't believe it. He asked a question because he was kind of my hero at the time. And then I left that talk and I walked out, and Ed Colgate talked to me. And Ed Colgate introduced me to Vincent Hayward. And I couldn't believe it because within 5 minutes, I knew now kind of the top people in that field, and they were so accessible to me. You know, as we know, Vincent Hayward passed away this year. And he was such a luminary, but more importantly, he was just such a nice person who could relate with you. And later on, in other conferences thereafter, I started meeting people like Hong Tan, Lynette Jones, and Alison Okamura, Marcio Mao. And they're also welcoming. So I think that in part that community is part of the big reason why I'm in haptics, because it's such a welcoming community. They bring people in, and it's such a diverse community in terms of interests and regions of the world. And I love all that.
But you mentioned you did your PhD also something related to touch. Am I correct?
Yeah, my PhD was related to touch. I looked at skin microstructures, and in particular, the ridges that are basically the ridge that's opposite the papillary, the skin ridges that you see, the fingerprints, and I studied how those ridges can influence propagation of stress through the skin, and how that might account, those ridges, that structure might actually enhance sensation.
It was not even related yet to human-computer interaction, right? It's more fundamental research on touch.
Right, that's right. That's right.
So why touch then, before you met this wonderful community, which indeed is?
The very first project I had as a graduate student, so basically there's clinical breast examinations are done, which are palpation exams to find nodules and tumors. And the very first project I had was to try to build basically a silicon model that you could move around the kind of tumors and masses in there. And that was the very first thing I worked on, was to build it was a simulator basically for training purposes. And I started to notice that I couldn't figure out why some people are so good and why some people are so poor. And it led me to looking at the finger and what are the differences we have individually, and what are the structures that could influence how we're perceiving these masses in the first place. And, trying to understand the person's perception as a way to design a system that can meet their needs. And that's how
Mhm.
I got more and more into haptics.
That's wonderful. That's a good kind of bridge to my next question, because you're someone who knows touch from kind of inside out, really, because some hapticians come from mechanical engineering, right? So they understand how to design actuation technology, things like that, but maybe not so in depth the understanding of the touch from inside, right? How it works, all these mechanoreceptors. So now having all this knowledge and this background, from your perspective, what do we still not know about sense of touch, and what should we know to bring current haptic technology or haptic technology aspirations, I would better even say, closer to realistic perception of touch? Or do we even need realistic perception of touch? Maybe there is some other substitutes, I don't know. Kind of
Yeah,
knowing your what you know.
some people would say, like what you just said at the end, that maybe we don't need to mimic actual touch, that we can play illusions and we can play sort of tricks on the perceptual system, and that might be interesting to do. My feeling is that even though haptics has been a very interdisciplinary field, that there's still kind of a group of folks that are building technologies, and those technologies are using whatever actuation sensing mechanisms are available. And then there's people who are really trying to understand the psychophysics of what should the design requirements be. And I think that we're not talking the same language a lot of times. And the psychophysics experiments need to start to inform directly the building of the equipment. Like, for example, we know that with softness, basically the rate of change of contact area and how the skin is moving, that's a very influential cue in determining, are you perceiving one softness versus another?
Mhm.
But we don't have, my group is trying to do this, but we still don't have good measurements on exactly how big should those contact areas be, how fast exactly do they need to change, and how do we need to move the skin to create that perceptual sensation of touching a deformable object. So I think, if we had numbers, if we had, okay, it's this Newton, it's this range of Newtons, it's this centimeters squared per second of contact area change or so forth like that, then I think it would be a little easier for the designers to start to build equipment to meet those specs related to the
Mhm.
fundamentals of human sensation. And I think that's something that we could probably improve on by, better interaction among the researchers.
Basically more precision, right, and kind of standardization that hapticians always talk about, lack of standardization. But you can say that standardization is possible, right? And I assume it is, of course, in some fundamental elements.
I think that it's possible to think about standardization. That's right. But I think how I'm thinking about standardization is I'm thinking about how do you move the skin surface. I'm not thinking about how do you move the actuator. And I think that there's
Mhm.
a difference between those two things. The skin is very complicated. It's anisotropic. It's got relaxation characteristics associated with it. It's very nonlinear. There's multiple layers. There's day-to-day changes. That's why I think it's very important to study the skin. There's individual differences that are.
Exactly. All these contextual elements, as you say, like, I don't know, humidity level, or again, level of relaxation, etc., etc. But I guess, yeah, without studying it, we can't even approach closer to this, right? So in some of your experiments that you do with your students also, right, you try to understand how finger surfaces perceive softness, right? And you already mentioned that also it's called sense of compliance, right? Just for the audience. Could you please talk more about the reasons behind this particular research, right? Trying to understand the perception of softness, and why softness and what are the potential use cases uh, for this type of research?
Sure. So I think traditionally, if you look at the neuroscience research, people like Roland Johansson, Ken Johnson, and others, a lot of that research involved rigid body stimuli, edges, gaps, spheres, and mostly they're rigid bodies where they're pressing into a receptive field and doing spike recordings. And that is the case with a lot of the modeling efforts as well. The mechanical engineering modeling efforts have been rigid bodies. And I would say a lot of the psychophysical studies as well have been like that. But I think that what we really interact with are doing things like touching the hand of another or of picking up an avocado and trying to determine if it's ripe for safety reasons, really, of grooming, where you're touching hair, which is soft, or you're touching, like I mentioned, the skin of another, or you're doing things like massage. So I think that there's a lot of interactions like this that kind of evolutionarily we were tuned towards. And I think that compliant stimuli are much more representative of real nature than our rigid body stimuli. And I wonder if our sensory system was tuned to that. So there was like a number of years ago, I was talking to the person who's an Austrian professor, and he talked about a spider. And the spider is a jumping spider, actually, and the spider has a hair on it.
Right.
And what the spider does is it senses the wake of a fly going over the top of it. The fly flies over, creates a wake in the air. And if that flies too far away, that wake can't reach that hair. If it's close enough, then it can reach the hair. And that hair, when they did the mechanical engineering analysis, has been tuned so that a wake that is of a distance that the spider can actually jump to get that fly, it's tuned to pick up those kind of movements. If you
So
study,
what are humans tuned to?
so that's what I'm saying with softness. What he talked about was if you move that hair and you move it in a way that's not related to the spider, then it's junk input. And those neurons that are innervating that hair are going to fire, but it might not really mean anything because that spider was never tuned for that kind of a stimulus. So that's my concern sometimes about rigid bodies. Are we really tuned to that? And I think that we need to think about what were the stimuli that we were tuned to. And I think, people like Sliman Benzmaya, who looked into different roughnesses and surfaces like that, and he looked at different textures, that I think was going in that direction, which are much more naturalistic. When you feel something like a denim versus a silk versus, so forth, I think that's a very naturalistic approach to understanding how neurons fire. And I kind of think of compliance in a similar way to that. I think that it's naturalistic as it ties to these evolutionarily derived experiences we've had.
And have you thought about any compelling use cases for this knowledge? So now, okay, let's say we know how we perceive softness, what triggers it, what are we tuned to, right? So what could be a good application of this
Well,
knowledge
I
in
mean,
terms of technical tech, haptic tech?
Yeah, so personally, the one I'm most interested right now is massage. And
From which perspective? Massage is something that is a very common association that I also get in my experiments from people. Oh, it felt like massage, or yeah, something with massage chair usually, so if I have actuators on the back. But I think it's more than that, right? So can you unpack this in terms of like what exactly massage is?
sure, yeah. So, like you've probably had a massage, right?
Sure. I mean, I'm sure everyone at some point in their life.
I've had it from a chair. There's very nice chairs that give massages, and I've had it from a person.
Yeah, it's different, right?
And I think it's different, right? And when you have a person
Softness, again, back to softness.
I could ask you a bunch of questions actually on this, but I think with respect to, massage, we know that it works. And in the United States, you have to pay out of pocket, not with insurance will not cover massage. And people pay probably as a country, billions of dollars a year on massages because we know that they work intuitively. But believe it or not, there's no fundamental evidence on the mechanism for why a massage works. We don't know if it's causing the muscle or the skin to soften or that it's releasing some neurotransmitter somehow and that the nerve is calmed down and that's releasing pain. We don't know that if it's the clinician that you're interacting with, you have a particular relationship with, that you feel close to them, that they can calm you and you can calm yourself. And I think that there's a number of questions there, the neuroscience, the biomechanics, the social, there's emotional aspects that are tied into that I think are really interesting questions.
Mm-hmm. So, but back then, haptic tech, like what do we want to get from massage? Do we want to improve the technique? Do we want to just understand the fundamentals of perception of massage, how it helps? Or, I don't know, do we want to create super novel massage chairs? I mean, what's the idea behind it?
I think the first step is to understand and to understand
Mm-hmm.
what is effective. I think that the clinicians are very effective, but we just don't understand why exactly.
Mm-hmm.
I'm not thinking of it. I don't think that we should, I don't think that we're going to learn much that's going to retrain the clinicians per se. I think that they're well trained, they know the task, they're very good at it. But what I think that we need is evidence that these kind of manual therapy treatments work. I could imagine a scenario in the future where we don't prescribe as many drugs because there is hands-on therapy, and that hands-on therapy helps in many ways, social and all these different dimensions that I've talked about so far. I see that as a great opportunity, and in particular in the United States, because we have such issues with musculoskeletal related pain that relates to taking opioids. If we could really prove what are the mechanisms that underlie massage, it could be a game changer in terms of really helping people improve in their lives and functioning.
Mm-hmm. Sounds interesting. You mentioned about emotional connection, the clinicians and whether it's one of the variables kind of contributing to the benefits of massage, right? The benefits that massage provides to people. That leads to the next kind of a little chapter of our conversation, because a big part of your research is actually dedicated to social and emotional mediated touch, right? To understanding how we perceive different emotions through touch. And specifically, a couple of your studies were dedicated to categorizing emotional touch gestures and basically figuring out the standard variables that contribute to each emotional gesture. And by standard variables, I mean velocity and indentation, also placement on the body, etc. Would you be able to talk a bit about these studies, what you have done, what you found, and how can we harness our emotions through maybe mediated touch now, not just real touch, but mediated touch?
Yeah. So I think of it as there's discriminative touch, which I would put some of the compliance tasks into. And discriminative touch maybe involve manipulation of objects, determining, like with the avocado, different compliances and stuff like that. Then there's affective touch, and then there's maybe pain associated with touch as well. And in effective touch, I've been working, recently with Håkan Olausson, Sarah McIntyre, Sadnagi of Linköping, Sweden. And we've kind of flipped the paradigm of what I've been doing in my lab. So everything that I've always done has been we control the stimulus in every way and do a traditional experiment where we control the force, we control the displacement, we control the contact area, and so forth. And then
Mm-hmm.
in controlled experiments, you vary one factor after another. So we then, okay, 1 Newton, now 2 Newtons, now 3 Newtons of force. With affective touch that we've been looking into, we've tried to take a different approach where we allow one person to touch another person and they can do whatever they want to do. And if they want to tap, they tap. If they want to move in a lateral direction, they move in a lateral direction. And then what we're trying to do is back out what happened in terms of the physics of contact and understand why were different people employing different individual differences in terms of these contact interactions, and what were they trying to convey by those, and how did the recipient perceive those little differences. So to me, it's like quite a bit of a paradigm shift, because now nothing's controlled anymore. And we try to,
Right.
and we're basically using machine learning techniques to try to figure out what happens and how does that tie to psychophysical responses. And you have to set up the experiments in kind of clever ways. And also, how do those contact interactions lead to the firing properties of particular afferents? And where the group in Sweden is doing single unit microneurography in humans in those cases. So what we found, in the psychophysics part is basically that when we look at the skin and we look at one person touching another, we see that people make subtle changes in how they contact others. And those subtle changes in how they make contact influence a receiver's perception of valence and arousal, emotional
Mhm.
connotations of percepts. They're really small. So there's very small changes in how you contact someone, how you remove contact, how long you remain in contact for.
Mhm.
But that tells the receiver a lot, actually, about your intention and how much you really care. Just like when you have a conversation with someone and they stick around and they talk to you, or maybe they make better eye contact with you, you know that they care a little bit more because of those kind of cues. And I would think that's kind of similar to what we're seeing when we're looking at affective touch in these cases.
But basically, and I think that's also the title of your paper, where you say that you basically quantified social touch in a way, right?
Right,
Is it
right.
even possible? Because that's like, wow, right? Because
Yeah, so
there's a lot of notion that emotions are so, custom in a way and cultural dependent and all that stuff. So far like that, but now we are more standardized than we think.
yeah. So, the paper with Sarah McIntyre, what it showed was that with these 8 emotions that we took a look at that people were trying to convey to each other, there's some pretty strong similarities in how different people are conveying the same thing. It's not
Hmm.
exactly the same. There's certainly cultural differences. There's certainly individual differences, but there's some commonality that's shared between those expressions that we can sort of customize. So like, for example, when you do a happiness emotion, you're like a little more joyful with how you're moving your hands across the other person.
Hmm.
Trying to convey a sense of calming, you are moving really slowly in a lateral way across another person. When you're conveying sadness, your hand is on that other person for a period of time, kind of stationary, that fashion. And I don't think I was ever taught to do those things. Maybe I
But
saw.
even, yeah, sorry to interrupt you, but you talked about sadness, and I think I remember that in that paper you mentioned that I think sadness and love, they're kind of expressed in a similar way,
Yeah,
right?
yes, that's right. That's right. Yeah,
Okay,
so
that's very interesting, right? So these are like very, you would say, opposite emotions. I mean, depends on type of love, I assume, but you would
yep.
think love is something positive, right? Not sad. I mean, initially, but they're so similar. That's pretty interesting, I would say.
In many regards, those two are, and not along all of the physical dimensions that we were tracking, but they're similar to each other and on many of them actually. And I think those are, I mean, maybe it's because those are very deeply held emotions that we're revealing to another, or
Hmm.
maybe we resonate with the other person when we're delivering them more than, some of the other ones that we evaluated were things like gratitude. And I don't think that there's quite the emotional connotation associated with gratitude as there is with love, or there is with sadness, or even with
Hmm.
calming. So I think more work is needed to understand those two for sure and their associations.
Mm-hmm. But still, since you're already able to kind of somewhat quantify and categorize, right, specific parameters, right, as such as velocity, indentation, etc., and map those to a specific emotion, right? I assume some, haptic designers could probably take this knowledge and apply it when designing some actuation technique. What do you think about that?
I think that could be done. I have to say I'm slightly concerned about that, actually.
Why?
I'm not sure we want to convey emotions from a distance.
That's
Or
an interesting point. Tell me more.
I think that there's a move now towards AI, more machines kind of in our lives. And I can imagine if you could quantify those emotions, you could start off maybe where it's kind of like a telephone and it's still you speaking and it's still the other person listening. And there's something in between that's doing the transmission of the data. But I'm nervous that one of those people gets replaced at one point, and I'm not sure if that's good or not.
Well, yeah, I mean, there are so many, right? There are so many ways to look at it, right? We could also think about, I know, care homes, right? People who are in need of,
Yes.
human connection without having the human right on the other side, or also like intensive care for premature babies. I mean, there are some medical cases, more like medical cases. But yeah, this element of social, emotional touch on daily basis, it's something, yeah, something of a philosophical discussion moving forward.
Yeah, those cases you mentioned, absolutely. I think we could, I could imagine a scenario where you've got babies in a neonatal intensive care unit and they need touch and there's issues with safety. And I could also imagine the other case you're talking about, that other use case with an older person. But I'm nervous about, then are we not going to visit our grandparents anymore in person? I'm not saying it's bad per se, but I'm saying it does seem like there's a need for an ethical understanding of what are we doing exactly in that area.
Ideally, ethical developments should happen simultaneously, right, already now.
Yep.
But as always, it happens kind of post factum. Well, hopefully, we'll hope the best. But right now, we are more discussing into what is possible, right?
Yes,
I
absolutely.
hope only good people are listening to us with good intention. So far, you think that it is possible, right, to communicate emotions through mediated touch techniques, right? Whatever interfaces, displays, whatever you call them, variables. So there is such a possibility, right? People can perceive emotions through some actuation, or it's not yet there. And
Yeah.
the second question, second question is that what is the best way to do that, right? So if you look at this haptic language roughly, right, there are two ways, kind of. One way is to render real touch sensations, let's say caress on a hand or a tap on a shoulder, right, to make it as real as possible, or create some sort of arbitrary haptic messages, so-called haptic icons, right, that can also have specific parameters into it, like frequency, amplitude, etc., that can map to a specific emotional, affective response. So do you think the best way is to render real touch, or haptic icons can also be a way of communicating emotions?
I'd say yes for both of them. Remote touch is going to have to get simplified in some fashion, and the actuators are certainly going to have to be a simplified version of human touch because it's too complicated. The skin to skin contact involves temperature, deformation of the skin, humidity, wetness of the skin, and all those details convey, important properties. But an actuator that's going to do all of those things is going to be really hard to develop. I think there's efforts that people are undertaking in that direction though right now. Maybe people are using pneumatic mechanisms, maybe people are using skin stretch, people are using brushes and a lot of approaches like that. And I see value in the other ones that you mentioned as well, more abstract, not so realistic approaches. My guess is it's going to be somewhere in between until we
Mm-hmm.
get something viable. I view where I can contribute in terms of understanding how to quantify those interactions. And then I think that there needs to be a filter on those at some point to figure out which ones do we focus on, what ranges can we do,
Mhm.
and so forth.
Basically, what are the most important one, right, that can actually be reproduced using actuation technology, right? And which one of those are the most effective in achieving the effect we want, right?
Yeah, yeah. But I don't think we're that far away actually from some of those becoming reality. I mean, I've seen several works in the last couple of years. I can give some examples, like for example, Heather Culbertson and Alison Okamura had some work where they're using discrete vibrotactile actuators, and they look at propagation down the arm, where one actuator is turned on and then the next one at a certain latency and then the next one at a certain latency. I've
Mm-hmm.
seen that same group use pneumatic and hydraulic mechanisms as well, where they basically got kind of balloons and they're inflating the balloons and structures like that. Uh,
Mm-hmm.
I've seen a number of people in Kai in that community doing things with kind of a brush, like an actuated brush, sort of. And then I think that there's people doing things with heats as well, and a sense of temperature. And I think temperature is underrated. I think temperature is very important, and I think that wetness, I think that's underrated, but that's a very important factor as well.
Right, that's hard, right? Like, how can you imagine production of wetness in a way? Very interesting stuff, actually, that you're talking about, because it touches upon not only fundamental elements, but it's also about technology, right? How advanced can it be? And all of this stuff is prototypes, right? I mean, the main daily use of haptics, I would say, for a lane user is actually a mobile phone, right? Which has just one simple actuator, moving up and down. I mean, it's a more advanced one, or like just try going in circles, even more rudimentary one. But anyway, if you summarize, because I'm moving into our last chapter for our conversation, which is like future of haptics. And if you were to summarize your knowledge on haptics and sense of touch, what would be, or what do you think is the future of actually touch screens and mobile, devices as we know them now, from the perspective of haptics in that sense, of course?
I think it's bright. I think, it's hard to predict what's going to happen in the future. My guess is that those screens eventually, I mean, maybe this is my bias, but I think that they're going to start to become, you can roll it up, you can bend it, you can,
Mhm.
maybe it's deformable to a certain degree. Maybe you can then kind of slap it on your arm and wear it, and you can
Mhm.
interact with it on your arm because it's fitted somehow to your arm. It's formed that shape somehow.
Mhm.
So it seems like things are going more wearable right now, and there's people thinking about textiles and wearable clothing and projection onto one's surface, projection of circuits and things like that.
So it's more in the direction of a form factor more than in terms of perception of the
Yeah,
outputs.
yeah, yeah. I think the form factor I think is going to be a change. That would be my guess. I mean, I don't know. Like I said, I can't see the future, but um, it seems like people are moving in that direction.
Mhm.
And they're moving beyond just holdables, because before, when we had the Phantom and the Omni and those kind of devices, those were grounded devices, grounded to
Mhm.
the ground. And then there were these things that are holdable. And now I think there's things that are wearable, and there's rings and so forth like that. Now there's going to be clothing. So I mean, my guess is that we're going to have a continuation of things like that. And it's going to be more integrated with you, maybe in your physiological responses, making it maybe more intuitive. And I think it's going to be, as you can see with some of the VR stuff, I think it's going to be more customized to the individual,
Mhm.
where the
Right.
even the
Right.
HCI is going to be customized to the individual, not just the form factor, but how do you want to, live, and how do you want to interact? And
Mhm.
And I think that a lot of the machine learning stuff might help to facilitate that in the AI.
And I think also form factor will also lead towards more complex perceptual elements, right? Because
Yep.
if we have more surface now, right? I mean, it's also a cost issue, right? So like, can we add 2 more, 3 more actuators, haptics, right, into our device? But given that it's cheap enough to add, then the larger body surface, right, would allow for more, maybe more interesting perceptual effects.
Yep. One thing to think about is, in general, we don't like things on us, on our skin in a permanent fashion.
Yeah.
And so how do you do that? Like we've done some experiments where we put a really thin Tegaderm saran wrap on the skin, and that totally changes your perceptual sense of emotion, actually. Just putting a thin layer on the skin changes
Mhm.
your affect very dramatically. So will putting these devices on change that as well? I would have to guess so. And I think we're going to have to contend with that, as well. How does it change perceptual characteristics? How exactly should it affix to you? How do you take it off, put it back on? Yeah, I think those are going to be important factors.
Well, I'll see lots of new directions for research. I mean, the researchers in haptics will not be bored for sure.
Absolutely.
So this leads to my last question for you. Would you be able to share your future plans, research plans? Do you have any, directions that you really want to investigate?
Sure, sure. So I mentioned
If it's
massage.
not a secret, of course.
Yeah, okay. I'm pretty open for better, for worse. I'm very interested in massage, actually, just because
Okay.
I think among all the areas that could have the most societal impact in a positive way, and I think that it could really have a major impact. If I just see a future where maybe we leave work every day with a massage, actually, whether that's
Mhm.
technology done or whether that's a real person doing it. But I think that it could really improve our lives, and I think it wouldn't actually cost that much at the end of the day. I think it could give jobs to people, which is really important too.
Give
So
jobs, not take jobs.
I think new jobs actually, not tech jobs per se, but
No, no, I said take jobs because I would assume if you have like tech type of enabled massage, you would take a job from someone who does massage manually.
I think the number of people who will do a massage will increase actually. And
Mm-hmm.
and I think that the technology could be supportive, but not I don't think it's going to be a replacement, because I really think you need the actual person there. It's just
Mm-hmm.
it's to make it custom to you, that's one thing, but moreover, to have the emotional connection, to understand how are you breathing at that moment, all those little elements I think are super important, and the massage therapists are very attuned to those. They're very good at it. So I think that it could actually add jobs. Um, and I think that's an important piece that I'm excited about.
So
So
you
that's one.
want to kind of investigate the fundamental elements of massage, right? What does it do to us, basically, right? How
Yep.
does it work?
And one element that I haven't really talked about is when you get in and you look, there's the skin, there's the muscle, and there's subcutaneous fat in between those two. But when you have a trigger point, believe it or not, we don't actually know where the trigger points are. When you feel a knot in your back and so forth, we don't
Mhm.
understand the cause of that. We don't understand how to get that remediated and helped out. Um, but it's
Yep,
possible
we
that
do
that's
AI technology, but we don't know how the brain works yet.
we don't know. But there's fascia tissue in between those muscles that has not been studied, and that is super important. And I think that's a big part of the future. I'm very interested in that in the future too.
Mm-hmm. Okay, that sounds very fundamental. And I subscribe to massage totally. I think it's really, really worth course to relax the world finally.
Yeah.
Well, thank you so much. I really enjoyed our conversation and quite learned a lot actually myself during this short talk. And it's been almost an hour, so thank you.
Yeah. Thank you, Yulia. I appreciate your time.